Okay, well, my computer says 11 a.m., so I'll begin. Well, first of all, welcome. Thank you for coming once again. Today is Saturday, July 29th, and we're in the dog days of summer here in Falls Church, Virginia. So today we're going to be talking predominantly about defining functions and using modules in Python. But before we do that, let's do a few preliminary things, as I always do. Quick look-see at the materials, and it's pretty much the same old story. Got slides. And by the way, let me show you something about the slides. I don't think I've ever mentioned this, but if you on the view menu in PowerPoint, you have my PowerPoint slides. If you go over and you say notes page, well, this one's a little garbled, but you'll notice that there's a lot of notes on each page, and that's the stuff generally that I talk about. So I don't know if that interests you, maybe it doesn't, but if you wanted to get all of my notes as well, if you print it out in notes view, you'll get that. So we have that. And we have scripts. They're not that many scripts today. I've never run this course in this format, so I kind of make a guess on what is 2.5 hours worth of content. And for example, in day 2, I underguessed. If we run out of material about functions and modules to talk about, I'll just slide on to the next topic, which is lists and tuples. We'll start talking about data structures next week. Okay, so we have the scripts. We do have more programs this time, so that will probably fill up some time. And they're a little bit more detailed. They're more intricate. Most of them are games, kind of silly games, but kind of interesting in demonstrating various functions that you can import, various modules that you can import into Python that have a whole host of built-in native, what I call native functions. And then there's the exercise for the end. So let's see, let's look at the exercise for the end of last week. And I don't know if anybody have a chance to give this a try.
Yeah.
Okay.
Yeah.
How'd it go?
Not for me. For me, I'm still struggling through it. I wasn't able to finish it.
Okay. Well,
I think I finished it. It was a little bit easier because we used the modified one that you gave. Like you already gave us a base, so modifying it from that base and going from there wasn't as bad as trying to do it from scratch.
I tried doing it from scratch, but I'm going to do it, and if I still have a problem, I'll email you to let you know.
Okay.
Where the problem lies. Yeah, I didn't have a chance until earlier this morning to do it, so that may be part of the reason too. But I worked on it for about 2 hours and didn't. Wasn't successful, unlike the other 2 exercises I did.
Well, again, they do get a little more challenging with each week. None of them are showstoppers, in my opinion. But there are some delicate things, some intricate things, little details that you have to attend to, or it doesn't work right. And we'll take a look at that. Okay, so I could read all of this stuff, but this is modified the test scores program. So I gave you the starting program, which had some problems to it, and they were supposed to have some problems to it. So what you were supposed to do is modify this so that the output would look like this. Okay, and in the original, the starting program, the safe word or the end word was end. And if we go through this, it's really not too complicated, right? It prints out these headers, and most of it is embedded in this while loop. In fact, there's a while loop within the while loop, but this outer while loop controls, as is typical in many of these programs, controls whether it allows the user to enter a yes or no to keep on playing, to keep on entering test scores and keep using the program. Okay, and you'll notice, and this is very common. That is, it's a template scenario you can use in a lot of programs where we initialize more tests to be a string, lowercase y, and then in the outer while more tests dot lower, and of course this is a method that if they enter a capital Y, it'll just change it to a lowercase y. While this is true, right? That's how while loops work, while statements work. Well, this is true. It'll go through this, everything within this outer while loop again and again and again. Well, what does this do? Well, if you go down to the end, the indentation, of course, tells you what the blocks of code are. So for this while, you just go all the way down here to print, but it effectively ends here, where the user here, let's display it, let's run it, and then we'll talk about it. So we run this, and
Professor, real quickly, I had a question. What's the difference between a double equal sign and a colon equal sign?
Okay, that's a very good question. The colon equal sign is an assignment operator. This thing is the walrus. It's called the walrus operator. It's got a colon and it's got an equal sign, and they call it the walrus operator because if you turn it 90 degrees, it looks like a walrus, 2 eyes and you got a tusk. Okay, so what it does 2 things at once. It assigns and it tests. That is, it is both an assignment statement and a Boolean, which will return either true or false. Okay, so it's a little more complicated than input statements that we've used in the past. So, but it does fire up this input statement, right? It says enter the test score. So this is the point at which somebody enters a test score, but it also assesses it's the conditional statement that triggers this while. So this entire thing here is a true false. This entire thing is a Boolean, right? So if it's not end, and again, I hate nots because, exclamation point equal means not equal. So what this is saying, if what the user enters is not end, you go through this all over and over and over again. And it assigns whatever the user enters, it assigns it here. This is what a walrus operator does. It does 2 things. It does assignment. So whatever the user enters gets assigned to this variable, and it is a true false statement. Both things, okay? Which makes it more complicated. And frankly, I don't like them that much, especially with a not. So that's what that does, right? So that fires it up here. Let's run it. I'll make this big so we can actually see. So you can enter scores and as many as you want, and pretty simple. Notice I'm only entering integers, and we'll see why in just a second. And then when I want to stop, I type in end, right? And it tells us here, enter end to end input. So I enter end, and it does its thing, which is just to add up all the scores so far and to take the average and to ask you whether you want to do it again. Okay, so let's say, yes, we want to do it again. But there's some problems with this program. And here's one of them. If you enter in a real number, and, I teach college classes, and some people, you could get an 80.5. It doesn't have to be a whole integer. But if you do that, you get a runtime error. You get an exception. And it tells you runtime errors are pretty good in being descriptive, right? This is a class of error. Value errors we'll see probably if not next week, the last day. Python is an object. It's an object-oriented language, And all of the native Python objects belong to classes. And this is a child class, a subclass to the parent runtime error class. And it tells you exactly what type it is. It's a value error. The user entered a real number, a float, and it only accepts integers. Okay, so that's one problem with this program. You can only enter integers. Another problem, and when I say problem, I mean it's not elegant. It doesn't, they didn't idiot proof it. They didn't do any data validation at all, really, or very little. But for example, if you run it again, let's run it again. And let's say I do this and I say, oh, you know what? I don't want to enter any test scores. So I enter end. Again, another nasty old runtime error exception. And the class, the descriptive class of the error is that I tried to divide by 0. Well, how on earth did that happen? Well, let's go back and look at the program. And I asked you to fix these things in the assignment. I asked you, one, to change the keyword, the stopping word, to stop. And two, as we'll see, I asked you to fix this so that if they enter stop right away, you won't get an exception. Okay, well, why does this exception occur? Well, let's take a look. It occurs because, let's go back up here. So we have we have one counter, and this one counter is going to just count the number of tests that are entered, and it is initialized to 0. Well, where does this counter get incremented? It gets incremented here. And well, what does that mean? Well, so at this point, if you enter end right away, which is okay, it's input is expecting a text, right? The input function returns a text. So test scores at this point would be the string END, but counter would still be 0. It wouldn't do any of this stuff because the test score is not greater than 0 or less than 0. And it would print this out, test score, or it should. But the problem comes down here, right? It tries to divide the score total, which of course is still 0, by the counter. And the counter at this point is 0. So if you enter end, the counter is still 0. When you get down here, you try to divide by 0, and that's where we get that error. Okay. Now the other error, the one where I try to enter a real number, well, that's pretty easy to spot, and it comes from here. Okay. So you enter a test score, and note the way this is what I would call architected. Input will return a text. Yes, input will return a string. So at this point, 80.5 is a string here. Okay, but then in the very next line, they change it to an integer. Okay, but integer doesn't like real numbers. So this is where it blows up when you try to force the float to be an integer. You get a value error.